This is the second part of the video series, The Library of Functions. Today we're going to talk about the power function. The square or quadratic function is a power function of the form f of x equals x squared. The graph of the quadratic function is a parabola. The properties of a parabola are the domain is all real numbers. The range is any number that is greater than or equal to 0. If you look at this graph, you can see that we are not going to be able to get out any y values that are negative. The lowest y value that we can get out, the smallest one, is 0. And we do get 0 out, so therefore we will include 0 in our range. And then we will be able to get out any y value that is positive. This function is decreasing from negative infinity to 0. The y values decrease there. At 0, it turns and begins to increase from 0 to positive infinity. Please note that when you're doing increasing and decreasing intervals, you always use parentheses, even if you have a number, because you cannot increase or decrease at a number. At one number, your function is constant. The y value stays the same. It doesn't change. When it moves away from that number over an interval, you can tell whether it increases or decreases. The x-intercept of the quadratic function is 0, 0, which is the origin. The y-intercept is also 0, 0. The cube or cubic function is a power function of the form f of x equals x cubed. This is the graph of the cubic function. It's a curve that goes through the origin and is in quadrants 1 and quadrant 3. The properties of the cubic function are the domain is all real numbers, the range is all real numbers, it is increasing over its entire domain. As I look at it from left to right, the y values are constantly increasing. It may look right through here as if this is constant and it's not changing. However, the y values change rather rapidly through here, and then they turn and begin to change by very small amounts here until it reaches 0, and then they continue to increase and change by very small amounts until it reaches a number where it begins to increase quickly. So don't get this confused. Just because we can't draw it and show all the little increasing increments through here, it is still continually increasing, getting closer and closer and closer to 0. It hits 0 and then begins to get bigger and bigger and bigger. It does not decrease and it is not constant at all. The x-intercept and the y-intercept are both 0, 0. The power function is a function of the form f of x equals ax to the n, where a is a real number and it cannot be equal to 0, and n is a positive integer, greater than 0, and is an integer. When n, this exponent, is even, then the graph of the power function resembles a parabola. It's a U shape. So the properties are the same properties as that of a parabola. The domain is all real numbers. The range is any number that is greater than or equal to 0. It is decreasing from negative infinity to 0, and it is increasing from 0 to infinity. X-intercept and y-intercept are still 0. The graph of the power function when n is even will always contain these 3 points: negative 1, 1, 0, 0, and 1, 1. The power function where n is an odd integer, if this number is odd, then the power function will resemble the cubic function, the S shape. It will still have the same properties as the cubic function. The domain is all real numbers. The range is all real numbers. It is increasing on the whole domain, and it will never be decreasing. The x-intercept and the y-intercept are still 0. The graph will always contain the points negative 1, negative 1, that's here, 0, 0, and 1, 1. So we want to know now, well, what happens with the power function as the exponent increases? We must look at each case individually. So let's look at what happens as the exponent increases when the exponent is even. So the first graph is the graph of x to the 4th, the second is x to the 10th, and the last is x to the 18th. I hope you will see that -1, 1, 0, 0, and 1, 1 are on all three of these graphs. What happens as this exponent gets bigger is the graph tends to flatten out between -1 and 1, and it gets steeper when x is less than -1 and greater than 1. So from here it begins to get steeper as the exponent increases. So between as the exponent increases in magnitude, as it becomes bigger, the graph gets more vertical when x is less than -1 or greater than 1. Okay, that's these places. And near the origin, between -1 and 1, the graph flattens out and it lays down closer to the x-axis. So when we have odd numbers for our exponents, the same idea happens. Notice that the numbers -1, -1, 0, 0, and 1, 1 are on all three of these graphs. But as the exponent increases in magnitude, as it gets bigger, the graph becomes more vertical when x is less than -1 or x is greater than 1 for each one of these. When we have x is near the origin, in other words, between -1 and 1, the graph will flatten out and lie closer to the x-axis.